Calculus kids, this is Dr. Callahan with week 3 Thursday. How are you guys doing? Sorry I'm not there today. My two older sons go to Ballin Mountain Elementary School and they had an outbreak of COVID, so they ended up shutting down the school since last Friday. And so between my husband and I and my mom, we've been kind of taking shifts out watching the kids because they're not old enough to be at home by themselves. So Thursday is my day because I didn't want to leave you guys unattended for the first few days of class, especially since we just came back from distance learning. But anyways, I'll be back on Friday. So today you guys are just gonna go over my lessons online with a video, and I don't want you guys to miss anything. So everything will be copacetic and you will be on track with the AP exam. So with that said, go ahead and pause the video and answer the following 3 questions. Okay, I'm gonna go ahead and create the assignment for you guys for the purpose of your attendance and then also for part of your participation in class. And so today is gonna be the first day that we're gonna talk about a new concept of U substitution. And it's exciting because this unit is very elegant in a way that you are solving equations with calculus, and it's very beautiful in a sense because you have to be very creative to get to the right answer. So this is where I feel like with calculus, math is really fun because it's very innovative. You can find all these creative ways and strategies to go ahead and get to the solution. So for this one, it's calculus semester 2. And today we're going to talk about intro to U substitution for integration. And I should put a strategy for integration. Okay, so just watch the video, view the assignment, upload your work. Can you continue for week 3 of Math Excel and complete your week 3 Wednesday assessment. If you did not, if you're not here in person with me on Wednesday, you probably didn't take the assessment, but just go to week 3 Wednesday's assignment and you'll have that. And as always, this is due by 3 p.m. of class. So I'm going to go ahead and click assign. All right, so your guided note today is going to look fairly simple for the most part. I'm not going to attach it mainly because I'm seeing you guys in person now, and if you really need to have the access to the hard copy, you can either pick it up outside of my classroom in B1 because I do have them there, or you can go ahead and go up to week 1 Monday of this assignment, and I have it attached for the first 9 weeks on a PDF. So yeah, let's go ahead and get it going. And okay, so here we go. All right, so let's go over the question on the warm-up. So this one here is for your integration when it comes to absolute values. And I always ask you guys to kind of draw the picture and then find the area using the 2 triangles. But there are other ways that you can find this as well. And so I thought today we'll try the other way of finding this, which is just by simple integration. And if you guys take a look at this here, keep in mind that with absolute value, remember the absolute value is talking about distance from 0, and there's always going to be 2. Like, for example, if I say what is the absolute value of 3, it's saying if this is 0, the distance from 3, you can go 3 units to the right, 1, 2, 3. So the space here is just going to be 3. And similarly, if I ask you what is the absolute value of -3, you go 1, 2, 3 to the -3. And again, your answer is still a positive 3 because it's not talking about a numerical number, it's talking about distance, and your distance is always going to be positive from 0. So when I take that account into the absolute value of x minus 2, you got to think about one is going to be a positive x minus 2, and the other one is a negative x minus 2. So if I distribute this, I have a negative x plus 2 and just x minus 2. So next, what I need to think about is the fact that I have my lower bound kind of reversed because a smaller number should be there. So if I were to go ahead and rewrite this here, I'll have the integral from negative 2 to 4, absolute value of x minus 2, but you will have a negative in front of that integral. All right, let's go ahead and proceed with this. So then I'm going to have two separate integrations. One's a negative from, and if you think about this, if it's going to be from negative 2, 1, 2, so here's negative 2, to positive 4, 1, 2, 3, 4. Well, where is the distance in between them? It will be here, or excuse me, actually. It will have to be at positive 2 because this is going to be your vertex at 2, 0, and your picture is going to look something like this. Okay, so then on the left side, you're going to have an integration of negative 2 to positive 2, and you have a negative x plus 2, plus the integration from the right side from positive 2 to 4, and you have x minus 2 dx. All right, so let's go ahead and find the integration of the first part. Now remember, it's going to be a 1 plus 1, which is a 2. So when I divide it by 2, my integration is being negative x squared over 2, plus integration of 2 is just 2x, and I'm going to evaluate that from 2 to negative 2. Similarly, I'm going to go ahead and take a look at this second integration. So I have 1 plus 1, which is a 2, divided by 2. So I have an x squared over 2 minus 2x, and we evaluate this from 2 to 4. All right, let's go ahead and plug in the upward bound first, and I'm going to have 2 times 2, which is going to be a negative 4 over 2, plus 2 times 2, which is a 4. And then I'm going to have a minus. I'm going to plug in the lower bound. And my lower bound is going to be you got to be careful with this because it's a negative 2 squared. So that's a negative 2 times negative 2 is a positive 4. And that's going to be a negative 4 with the negative here, so don't mix it up. Divided by 2 minus 2 times negative 2 is a positive 4. So I'm going to have a negative 2 here, negative 2 plus 4, plus distribute the negative, that's going to be a positive 2 minus 4. So then altogether, that is going to give me a 0. Plus, well, actually, that doesn't look really right. I'm doing something incorrectly. Yeah, because that's not a 0. That can't be an area of 0. What am I doing incorrectly? Let's see. If I make that into a positive, and if I assume that this is like a negative 2 squared, that'll be a positive 4. And then that'll be a positive 2. So then that will give me a 6. And this here is going, okay, so I think what I'm thinking about this is I'm thinking of the fact that this negative is actually in like this. So that would change it. Sorry about that, guys. So let's just go back to this one more time. So then when I plug in the lower bound of this negative 2, it's a negative 2 squared. There you go, which is a positive 2 squared, which is going to be a positive 4. So that'll be a positive 4. So then this will be a negative 2 minus a 4. But see, then that still doesn't actually help me get to a positive number. It still gives me to a negative, and I know I'm doing something wrong, but I, for some reason, cannot see it, and it's really making me a little bit agitated with this, but that's okay. But ultimately, I'm going to eventually find out. I'm sorry about that. But ultimately, you should be able to get somewhere to like a 6 minus 2 for this part, which is going to, or negative 2, which is going to give you an 8. Okay. And then let's take a look at the right side. I'm going to eventually find this one. I apologize. I can't really see it right now, but it's there somewhere. So you plug in the 4, which is going to give you a 16 over 2, which is an 8, minus 2 times 4, which is an 8. Minus, oh my goodness, I feel like I made the same mistake again. But that's okay, I'm being optimistic. 2 times 2 is a 4, 4 divided by 2 is a 2, minus 4. So that's a 0. That's a negative 2 plus 2. And it is, this part is correct. I'm making some kind of a mistake over here. I'll eventually find it. Plus a 2, which is going to give you a 10 unit squared. And that is going to be your answer for this. But I am making some silly integer mistakes there that I just for some reason cannot find. But anyways, let's go ahead and move on to today's stuff. So today's going to be the first day on U substitution. This is going to be the breakdown. I'm going to go over some examples with that. If you missed yesterday's quiz, make sure you go ahead and take a look at week 3 Wednesday's assignment. I have it up there, and you could just show your work on a separate piece of paper. So today, I would like you guys to go ahead and take a look at this. After our 7 examples on USub, I would like you guys to go ahead and read Paul's notes on definite integration with USub, which is on this tiny URL right here. You guys can go ahead and type that in to get more examples, or if you want to know like some of the historical background information of why we use USub, I do have that there. All right, so with that said, let's take a look at your guided notes for today. So turn over to week 3 Thursday, and it starts off with this page here. So you will have my notes on USub with different examples. It's 2 pages. Just kidding, not 2 pages. It's actually 3 pages. And then I have some additional examples right here that you can take a look with the steps. This is going to be your notes in class today that we're going to go over in class. And then, of course, more examples with USub method with the steps in addition to everything else. So I want you guys to try these examples at home. If you are stuck, go ahead and read the examples right here on this tiny URL. And then just some more additional practice problems. Okay, so with that said, let's go ahead and get started then. And let's see, example 1. Okay, so example 1. If you take a look at this part right here, it's kind of like a chain rule. You know what I mean? So far, there are several ways you can do this. You could either FOIL the top and then distribute the 2x to make it into a polynomial, or you can go ahead and use U substitution. So with U substitution, we're just going to say let U equals wherever the chain rule is. I mean, if you look at this right here, there's like a chain right there. You get it? So I'm going to say let U be x squared plus 1. Because if I were to find the derivative of this, I will bring down the 2, and then I will do x squared plus 1. 2 minus 1 gives me 1 times. And then this is, remember, the derivative of the chain, which is a derivative of this part, which is 2x, right? That's why you want U to be right there, because that's where the chain is happening. So then once you have U equals x squared plus 2, then U prime is going to be, which is the derivative of this, 2x du. Sorry, 2x dx. Okay, so then what I'm going to do is I'm going to go ahead and replace it. So here's my integration. Replace the x squared plus 1 with a u squared times 2x dx. Well, here's a problem because I can't exactly find the integration of this because you have two different variables. You have to have only one variable. Okay, so this is where the substitution and the unique art of calculus kind of comes in for you to manipulate this. So as I'm looking at this here, I know that I can go ahead and perhaps change and replace the dx with something else. Okay, so then, whoops. So then another way of writing u prime is du, which is 2x dx. Now here I have a dx, and maybe I can replace a dx. If I solve for dx, then I know dx is equal to du over 2x, right? So then let's do the integration of this. Integration of u squared times 2x, you're going to replace the dx with a du over 2x. And then see what happens. The 2x cancels. Integration u squared times du. Perfect. Only one variable, u. So then let's go ahead and integrate this. So we're going to go ahead and do 2 plus 1, which is a 3, divided by 3. And so I have a u to the third power over 3 plus, don't forget your constant c. So now you're going to replace everything back to with u, because you knew that u was x squared plus 1. So I'm going to have x squared plus 1 to the third power over 3 plus c. And that, you guys, is your answer. Right there. Okay, so let's go ahead and practice using example 2. Okay, so with example 2, you're throwing in some trig functions. First, you want to identify where is the chain happening. I hope you can kind of see at this point that your chain is going to be right here at the 5x. So I'm going to say let u be 5x. So then your du is going to be 5 dx. And most likely you probably had to solve for dx, so I'm just going to solve it anyways, just in case. Du over 5. So then once I have this done, I'm going to go ahead and replace the 5x with the u. So integral 5 cosine u dx. Again, you need to have one variable. So what I'm going to do is I'm going to replace the cosine u dx with du over 5. And guess what? You can go ahead and cancel the 5's here. So I'm really just looking at the integration of u du. And you know that the integral of cosine is going to be a negative sign. So it's a negative sine u plus c. Now we're going to go ahead and replace it back. So negative sine u, which is 5x plus c. And that is your answer. All right, let's go ahead and go on to example 3. All right, example 3. So with example 3, where is your chain? I mean, it kind of takes a art form to find the chain, but eventually you'll get better at this. I see it right there. So I'm going to say let u be x squared plus 1. So the derivative of u, which is du, is 2x dx. And then dx is equal to du over 2x. Now let's go ahead and replace the integral with a u. X times u times dx. Okay, and once again, we only want one variable with u. So first thing I'm going to do is I'm maybe going to replace that part right here. So I'm going to have the integration of x times u times du over 2x. And yay, because I can cancel the x, so then I have the integration, and I can move the 1/2 out because it's a constant, u du, which means I'm going to have to do the reverse of the power rule, divided by 2. So my answer is 1 over 4 u squared plus c. So now let's replace everything back. So I have 1 over 4, x squared plus 1 squared plus c. And that is your answer. Okay, so let's go on to example number 5. Or sorry, example number 4. Okay, so example 4, I'm going to go ahead and give you the answer right there. I'm going to have you guys pause the video and give it a try on your own, see where you get to, and then I will go over the answers with you. So pause the video. All right, let's go ahead and give it a try. Where do you think the chain rule is going to happen? I would say it's probably going to be right there inside the square root. So I'm going to say let u be 2x minus 1. So your du is just 2 dx. Your dx is 2u over 2. Okay, next I'm going to go ahead and do my integration. And I'm going to do u to the 1/2 dx. But the problem here is I still need to have just only one variable, and it has to be in terms of u. So then what I'm going to do is I'm going to go ahead and replace this part here with du over 2. Uh-oh. So at this point, you're like, well, I cannot solve and continue this because I'm not able to get rid of x. So what do I do? Well, you definitely use this equation. You use this equation. We have not used the first equation. So maybe you can go ahead and solve for x in terms of u. So what that means, I'm going to add the 1 on both sides. U minus 1 equals 2x divided by x or 2 on both sides. X equals u minus 1 over 2. All right, so let's do that. Let's replace this x with that. Integral of u minus 1 over 2, u to the 1/2 du over 2. Okay, so first thing I'm going to do is I am going to go ahead and take the 1/4 out of this equation. So 1 over 4 u minus 1 times u to the 1/2 du. Then I'm going to distribute this u into the parenthesis. So I have u to the, and remember, this is a 1, so it's a 2 over 2. So 2 over 2 plus 1 over 2 is a 3 over 2 minus u to the 1 over 2 du. So with this one, you could think of it as we're doing the integration of both of these, okay? So if I go ahead and do that, I'm going to go ahead and add 2 over 2, which is a 5 over 2. So divided by 5 over 2. Remember, you got to flip that. So really that becomes a 2 over 5 u to the 5 over 2 minus 1/2 plus 2 over 2 is a 3 over 2. Flip that 3 over 2, you get a 2 over 3 u to the 3 over 2 plus c. All right, now don't forget your 1/4 because we're going to have to go ahead and distribute that back in. So let's go ahead and distribute the 1/4, but then also at the same time replace the u. Whoops, what just happened? How do I get out of this? Okay, here we go. So if I look at this, 1 times 2 is 2, 2 over 20 is 1 over 10. U, which is going to be 2x minus 1, to the 5 over 2, minus 2 times 1 is 2, 4 times 3 is 12, so 2 over 12 is going to be a 1 over 6, 2x minus 1 to the 3 over 2 plus c. And that is your answer. All right, let's go on to example 5. Okay, so as we're looking at example 5, another way of writing sine squared 3x is just sine 3x squared. Okay, remember that. So what are you going to have u be? We're going to have u be this piece right here. Okay, think of it as a foil. Like if I were to have, let's say, 2x minus 1 squared, you would go ahead and have your u be inside the parenthesis like we did before, right? So if u equals sine 3x, then du equals cosine 3x dx times, but before you do the cosine 3x, derivative of sine is going to give you a cosine, but then remember there's a chain right there, so you still have to find the derivative of 3x, which is 3, then dx. Okay, so then here I'm going to replace it. Integration of sine is going to go ahead and replace with a u squared, because remember your sine is going to be sine 3x is going to be u. So I'm going to have u squared times cosine dx. And how we went about with this is that you have the integral of u squared, which is that part right here, times cosine 3x dx. And then remember, you're going to solve for dx, so your dx is equal to du over cosine 3x times 3. And lucky for you, if you look at this here, do you see how the cosine 3x is on top, which cancels the cosine 3x on the bottom? But that leaves the 3 right there, so your 1/3 is right there. But with that said, it does give you a very nice clean picture of just having an integration of u squared. So then let's find the integration of that. 2 plus 1 is a 3, divided by 3, that's going to give you a 1 over 9. Okay, we're going to replace the u back with the sine 3x plus c. And that is your answer for that. All right, so let's go ahead and take a look at example number 6. With example number 6, you do have a definite integral with a lower bound and upper bound, and they are from smaller to biggest, so that's good. Okay, so then let's say let u be x squared plus 1. Du is 2x dx. Dx equals du over 2x. So once I have this, I'm going to go ahead and find the integral of x times u to the 3rd power dx. I'm going to replace the dx with the du over 2x, which is going to have the x and this x cancel. Move the 1/2 over to the left, cubed du. That'll be pretty simple because now you can just proceed forward with the reverse the power rule, which gives you a 4. So that's going to give you a 1/8 u to the 4th plus c. So if I go ahead and replace the u with x squared plus 1 to the 4th plus c. And from this point here, you want to go ahead and evaluate it from 1 to 0. If I plug in the upper bound of 1, you are going to get a 16/8. When you plug in the lower bound of 0, you're going to get a 1/8. So if I subtract the 2, I will get a 15/8 as my answer. All right, so let's go ahead and take a look at that last example right here. Example 7. All right, so as I'm looking at this right here, I have a fraction with the radical. I'm just going to say let u be 2x minus 1. So then du is just 2 dx. Dx is equal to du over 2. So integral of 1/5, x over u to the 1/2 dx. So then let's replace a dx. And this is going to be a du over 2. So that doesn't really help me. But hopefully, if I go ahead and solve for the first equation here, that will help me. So if I solve for x, I'm going to have u plus 1 over 2. So I have the integral 1/5 x over u to the 1/2 times du over 2 times, or actually I'm going to be replacing this x here with a u plus 1 over 2. Holy moly, that looks even uglier. So let's rewrite this. U plus 1 over 2 divided by u to the 1/2, which is the same thing as saying times 1 over u to the 1/2 times du over 2. Okay, so I'm going to move this out of the way. So I have 1/4 integral. I know it's 1/5. I'm just losing that piece, but that's okay. So I'm going to have u plus 1 times, let's move this one up. Or actually, if I don't move it up, I can actually keep it there and just, well, it doesn't matter. You can keep it there and then separate the fractions, or you can just move it up and then distribute it through times du. Let's now distribute this into this. So here I have a 2/2. If I distribute that in, what is 2/2 minus 1/2? I'm going to get u to the 1/2 minus or plus u. 1 times that is a negative 1/2. 1/4, so just keep that in mind. Integral from 1 to 5. Integral from 1 to 5. We're just going to have to do this separately. Okay, so then what I'm going to do is I'm going to do a plus 1, which is going to give me a 3/2. So divided by 3/2. Flip that. So that's going to be a u to the 3/2 times 2/3. Plus, here I'm going to add a 2/2, which is a 1/2, divided by 1/2. Flip that. So that's going to be a 2, u to the 1/2 plus c. Well, I don't care about the c, it's there somewhere. And I'm going to evaluate this entire thing between 1 to 5. Oh, wow, okay. So let's do that. 1/4, replace it. 2/3, replace a u, 2x minus 1 to the 3/2 plus 2 times to the 1/2, plug in the upper bound of 5 into x, and in this case, you might want to do either with your calculator, or you can go ahead and graph it and then do a second calc x value, whichever one works best for you. And when you dwindle this out and you subtract them, you will be able to get an answer of 16/3 unit square. And that is your answer. All right, guys, so this is really just the first day of USUB. We'll talk more about this later on. I will recommend that if you feel confident enough, maybe start practicing with some additional examples right here on this page, and then maybe move on and proceed with some of these questions over here on the next page. As always, stay safe and healthy, and I'll see you guys next time. So take care. I'll see you Friday.